Okay, we're going to run through the calculation of the nearest neighbor statistic using a function from ArcToolbox, and then we're going to actually calculate the nearest feature for these points using Hoth's tools. So here's a distribution of points that are actually specks of charcoal on an excavated surface in a cave site known as Chichen Ha. And what we want to do is determine if these points are clustered, clumped, and if they are, how much. So to do that, we're going to perform nearest neighbor analysis. And first we'll run it using the defaults here under spatial statistics, tools, analyzing patterns, average nearest neighbor. Okay, so we're going to include the point feature as the input feature class, Euclidean distance, display output graphically. For now, we're going to leave area optional open. And what that's going to do is to calculate the area based on a minimum enclosing rectangle. Okay. Now the function is going to run. It's got the graphical output. The observed and expected ratio is 0.57, and the z-score is -23.35, and that is very clustered. And if we come over here, we can actually see the z-score itself, and the p-value is so small that it just registers as 0. The very, very small p-value means that there's a very low probability that this is a result of random chance. So this is a clustered distribution. Let's try this again, but instead of using the bounding rectangle, we're going to use the bounding of the excavated space, which is that yellow polygon. And to do that, we need to know what that area is. The first thing we're going to do here is add a field. We're going to make that field area. We're going to set it to be a double because that's the kind of data that we need. And then we're going to come here, come up here to the field heading and say field calculator. It's going to give this error that we're not in an edit session, and we want to click on the advanced tab. We're going to click help. Here's the ArcGIS help for the calculator. We're going to scroll down about 2/3 of the way to where it gives the formula for calculating area from the field calculator, and then we'll just paste that in here. Now, prior experience has shown me that spaces here in the formula will result in an area, and that area is actually going to equal the output variable here, so it is going to be p area dot area, and then we say OK. And here the area has been calculated. So now we'll come back over to the nearest neighbor. We're going to make the input feature class be the points again. The input field is going to be, oops, this is high-low clustering. We want the average nearest neighbor. I didn't think there was a need for an ID field. Take the points, and leave the Euclidean distance. Yes, we'd like a graphical display. So what we're going to do now is take this 12.58 area, enter it in over here, and say OK, and rerun the analysis. So whereas the observed mean distance to expected mean distance before was 0.57, it's now 0.63, and the z-score has actually gone down a little bit to 20.05 versus 23.35. Now this is still a very, very clustered distribution, and this low p-value means that there is a very low probability that this is the result of random chance. So it didn't change much, but since area influences directly the result of nearest neighbors, sometimes just that straight bounding box is not going to give the best result. It's better to try to either record it empirically, the boundary of a set of observations, or try to produce an estimate that's a little bit closer than just a minimum bounding rectangle, because this area in here was included in the initial computation in this area here, but these weren't actually, there weren't any observations that were made in there, so it's better to eliminate that area. So let's close this. Now we've run the nearest neighbor statistic, which has told us that this is a clustered distribution, but we don't yet know how close any two of these, what is the closest feature. Say for this feature here, what is its closest one? And to calculate that, we're going to use something called Hoth's tool. So you right click out there in the gray area, that'll bring up Hoth's tools, happens to live over here. Main analysis tools, and then distance between points within layer. Point locations layer is going to be this guy. We're going to set the FID as the unique value. And then output here, there's several different options for the output. Really all I want is the summary statistics here. And then I want to create a file that's going to give the nearest neighbor for each point, and I only want to find one. And I'm going to make a delimited file, and then here this will be, we'll just write right over this guy. Well, let's call it Hoth out 2 and save it. Okay, I'll look here, it's going. Processing is complete, and now we can go see what the result looks like. Please. Okay. And so this is one of two tables that was created. Here's the other table. And let's look at the first one that I opened first, which is Hoth 2. Now for each point, which was originally the F, this was the FID. It's been renamed UID, but it's the same series of numbers. It's got the minimum point, the maximum point, the mean distance, and the standard deviation. And one thing that I like to do to make this a little more readable is I format the cells number, and we can be very robust and give it 4 decimal places. And now we see for each point it gives the minimum, maximum, mean, and standard deviation of the other observations that are in the distribution. Now let's look at the other table. Okay, and this just gives the distance to the nearest feature, and then it tells the user which feature that is. Okay, which is kind of nice. No, I don't want to save changes to that guy. And then this, so this could then be joined in to your original table. So that's how to calculate the nearest neighbor statistic, and then actually figure out the distance to the nearest neighbor and identify which neighbor that is.